Okay, on these problems, we're going to be looking at more stuff with combinations, in particular the idea of working with things like lotteries. Now, the important thing right here is order does not matter. So when order does matter, that's the important part right there. When order does matter, you have to use different kinds of calculations. That's where you use permutations or you're just using straight counting techniques. Now, the one that I typically use, and again, keywords you're using are combinations, groups, sets, picks, number of cards dealt. The main one I use is this NCR, and the one that I saw your book using was the combination formula where it puts N over R, almost like a fraction without the bar. Now, in my calculations, I'm going to tend to use this one because it's easier for me to actually type in and to utilize. So just realize that these two things mean the same. Now I want to give you some reminders about using it just in case you have to calculate it by hand. Now I'm going to assume that you have a calculator that might be able to do this calculation. And I'm going to show you a graphing calculator that if you don't have, I would suggest getting. That would be really good for the class. Okay, let's say you got 50, choose 5, written in this format, again, the one your book had. And the way you also might see it is this way, 50, choose 5. This is the way I'm going to enter into the calculator in a second. Now I'm going to first calculate this thing out and show you how you do it by hand, just in case you have to. So remember, a factorial means 50 factorial, means all the numbers from 1 through 50 multiplied against each other. 5 factorial will be 5 times 4 times 3 times 2 times 1. 45 factorial is 1 through 45 multiplied against each other. So if I extended these things out, what you would do, 50 factorial go all the way down to 1. Here's your 5 factorial. Here's 45 factorial. And we would be able to reduce all of these. All those, when I put 45 over 45, 44 over 44, those all become 1. Leaving you with this. Now you can do further reducing if you want. 50 goes into 5, so that would reduce down to 10. 4 times 3 is 12. That goes into 48 4 times. I can take 2 divided into the 46, giving me 23. A lot of things you can do to simplify it. Now, I want to show you on the calculator if you have this as an option. So here it is. Here's the calculator. And slide it on. Okay. So on the calculator, I'm going to turn this thing on. Okay. So what you would do, let's say I'm going to do 50, choose 5. So I'm going to type in 50. Then I'll go over here where it says math. Go over to probability. And then I'm going to go down to number 3. I go 50, choose 5. I hit enter. And that's what 50, choose 5 equals. So we'll see it on the next page when this number actually comes up. Now, underneath this math menu, you'll see all the probabilities. There's the factorial. NPR stands for permutations. That's when order does matter. Combinations, order does not matter. So you may have something that's kind of equivalent that you can actually use. Okay, so just continuing on with the PowerPoint. We're going to look at a lottery problem. This is actually the same one you had in your assignment, just to kind of show you how the calculations are done and what happens. So if you have a lottery where you have 55 numbers and the player picks 5. Now their goal is to try to get all 5 of their numbers picked. We want to see how likely this is. So when we do the combinations right here, if we want to find all the possible combinations, it's going to be 55, choose 5. This represents all the combinations. So we'll see this number come up in a little bit. Now, you have 5 of the numbers. You don't have 50 of the numbers. So, if you're going to get 0 numbers correct, that means from your 5, you're going to choose 0. For the remaining 50, they're going to choose 5. Notice how these two numbers, the 5 and the 50, add to 55. The 0 and the 5 add to 5. So it's a 55 choosing 5. So that's where you're seeing this part of it coming in. 5 choose 0, there's only one way, basically this equals 1. And if you ran through the calculations, you can see that. 50 choose 5 is one we just got finished doing a little while ago. So that's going to happen 2,118,760 times to get one number. Now, 0 numbers times the frequency gives me 0. So I'm just doing match times the frequency. Now, for one number, you choose one number of yours gets picked, while 4 of the remaining 50 get picked. Again, 5 plus 50 is 55, 1 plus 4 is 5. When you calculate this out, you get 1,151,500. 5 choose 1 would equal 5, and then this one you'd have to do on a calculator or do it by hand. Then I do 1 times that number, and I get just the same number back. If I do 2, that's 5 choose 2, so 2 of your numbers, and then 3 of the remaining 50 gives you 196,000. I'm going to multiply that, the match, number 2. I'm going to take 2 times 196 to get the total over here. 3 numbers, it's 5 choose 3 times 50 choose 2. It's 12,250. Take that times 3. Gives me 36,750. 5 choose 4. And then 50 choose 1. This right here, 5 choose 4 is equal to 5. 50 choose 1 equals 50. So I got 250 ways of having that happen. Then I did 4 times 250 to get my match times the frequency. Now I'm using this because we want to try to figure out what is the expected number. Now all 5 numbers, well 5 choose 5 equals 1. 50 choose 0 equals 1. So both of these equal 1. Then I do 1 times 5 gives me 5. Now the total possible outcomes comes from 55 choose 5. This is going to be the same as if I added up all of those numbers here. So there are 3,478,761 ways of picking 5 numbers from 55. Okay, now I want to go over and calculate out what is my expected number of matches I should expect on the lottery. How much would you expect on average if you played it over and over again? How many numbers would you expect? Well, it's overwhelmingly 0 most of the time, followed by 1. So it's probably going to be some number between 0 and 1. That's what you'd expect. Now to calculate that out, what we want to do is we're going to take our match times the frequency. So we're taking whatever our outcome is, which would be 0 numbers, times how often they occur. And I'm going to multiply those numbers together, and then I'm going to add all these up. So I find the sum of all those. This is the sum, and I'm going to divide it by all the numbers I have. So my expected, well, my match plus my times my frequency is this number divided by all the possible outcomes. Now, usually when you calculate an expected value, what you do is you're going to do the sum of your outcome, which is x, times the probability of that outcome. Now, the probability of getting 0 would be 2,118,760 divided by all the outcomes, the 33,478,761. This one, to get 1, I'd have 1,151,500 divided by the roughly 3.5 million. That's the probability of getting 1. So you take it and you're going to add up, and you might even see this notation. It's the sum, and they use this letter, it's called sigma, and it's x times the probability of x. That's how you find an expected value. But this is really nasty because of the fractions, because all of these would be over 3,478, 3,478,761. So I'd have to have all these fractions I'm adding together. Well, they all have a common denominator, so that part at least makes it a little bit easier. But I could also just simply add up all those products and then divide it by that one common denominator. So you'd expect to get roughly a little less than half a number at a time. So if you played it twice, you'd probably expect to hit one number. So that's why lottery odds tend to be bad. So now we're going to go through, we're going to show you doing calculation with the kind of a real lottery, and this is what a lot of your problems are dealing with. So this is one I'm going to look at. This is just called the California Lottery. The initial one they did was called Super Lotto. And this one makes it real clear. All the other ones work pretty much the same way, like Mega Millions or Powerball. They just use different numbers they're working with. So with the lottery, what they do is they're going to select 5 numbers from 1 to 47, and then they choose a mega number. This might be Mega Millions, actually, from 1 to 27. I think this is Mega Millions. So on this one, what you have is you have 2 different kinds of sets. From 47, and I want to know how many combinations are possible. From the 47, I'm going to choose 5. From the 27 numbers, I'm going to choose 1. Now this is equal to 27. So that's where this calculation comes out. So all the possibilities, there's 41 million different ways of winning. So that's how many different ways, a combination, not really ways of winning, but this is different combinations that you could have. So if you want to exhaust every single possible one on the lottery, this is what it is. I still think it's California Lotto, though. But it doesn't matter. The same kind of principles are going to apply for the problems you're using. Now, you only win under certain combinations. So that's what we're going to look at here. The winners, if you get this, if you get 5 numbers plus a mega, and there's only going to be one way of doing that, and on this particular example, I had a payoff of $13 million. You could win if you get 5 numbers, but you don't get the mega number. 4 numbers plus mega, just the 4 numbers. 3 numbers plus the mega, just 3 numbers. 2 numbers plus mega, 1 number plus mega, or just the mega number itself. Those are all different ways you win. So we're going to look at how to calculate out each of these, and that's what's going to go in the frequency. Now, in the examples you have in the book, they have some of them filled out. Sometimes they already have all the frequencies. And if I want to know what my outcome is, what my expected value is, I take the frequency times the payoff, each one, and then I'm going to add those all up and divide it by all the outcomes. Okay, so let's take a look at this first one. So you have 5 numbers. Now remember, they had 47 numbers. You have 5 of them. So if you're going to win, you need to get all 5 of your numbers picked, and you need to have the remaining 42, none of those picked. So what happens here, from your 5, you're going to choose all 5. This equals 1. For the remaining 42, you're going to choose 0. And you only have one mega number, so there's only one number you have to choose from. So when you calculate this out, this is 1 times 1 times 1. Frequency is 1. Now, if let's say you didn't get the mega number, well, there's 26 numbers that are not the mega number. So this one's going to be 26 you have 26 ways of not getting a perfect match. You're getting all 5 of yours and none of the remainder, but you do not get the mega number. Well, there's 26 numbers that are not the mega number. That gives you 26 different ways that could occur. Now for 4 numbers plus the mega, and every time we have the plus omega, this is going to be a 1. So now, from the 5, I'm going to choose 4. From the remaining 42, I'm going to choose 1. And then I have to get the mega number. Again, 5 plus 42 is 47. 4 plus 1 is 5. That's where you're going to get 47. Choose 5 as all your combinations. That equals 210. This one right here is just going to be 210 times 26, which is 5,460. For 3 numbers plus the mega, it's 5 choose 3 times 42 choose 2. And the mega, again, times 1. It's 8,610. If you just had the 3 numbers, I just take this number, multiply it by 26. 2 numbers plus the mega would be 5 choose 2, 42 choose 3. The mega, there's only one way to get the mega. And again, 5 plus 42 is 47. 2 plus 3 is 5. There's your 47 choose 5. There's 114,000 roughly ways of doing that. 1 number plus the mega. Again, I have the mega, so now I'm going to stuck with 1s every single time. Won't be using the 26 anymore. So you choose 1 number and then 4 remaining ones. There's 559,650. Just getting the mega number, that means you chose 0 of your numbers. And the remaining numbers came from, all the numbers came from the remaining 42. And again, just getting the mega, there's 850,668. Now, to figure out what's left, I've got to take all the possible combinations. There were 41,416,353 ways of winning, of drawing the numbers. If I added up all these and subtracted it from that 41,416,353, that's how I got the 39 million. That's how many ways you cannot win. So if you notice, most of the time you don't win. Okay, so you only have 2 million out of 41 million chances of winning. So now what we're going to do is calculate it out. So all we do is take your frequency times the payoff and then you're going to find that sum. So I'm going to multiply those across. So 1 times 13 million, 26 times 16,163, 210 times 23,009, or 2,309. And these are the totals. Now when I do this one, 39 million times 0, that's just 0. And I'm going to add up all those, and that is how much they'd expect to pay off. If everybody played all the numbers, let's say every single number got paid exactly once, this is what would happen. You'd have this much money paid out. They'd pay out 20 million in payments, but they collected 41 million because it costs $1 to play. So if it costs $2 to play, I'd have to multiply this by 2. So your expected value, I take my total winnings divided by how much money I would bring in. You would expect, on average, the payoff to be 50 cents. But it costs $1 to play. So that means you're going to be losing about 50 cents every single time you play. And that's assuming that the jackpot is this. Now, when you have the big payoff, the big jackpot, this increases if nobody gets it. So I'm going to just do one little quick other example using the same thing. And let's say the problem is, how much does this need to be in order for it to make it worthwhile to play? In other words, it becomes a fair game. Well, I'm simply going to change that 13 million into M. I would still do the same thing. I'd multiply all these across. And again, most of the time you're going to lose, so this would be a 0. If I add all those together, which I'm going to get rid of that. So now when I add up all these, because this last one would have been 0, I have 7,717,556 plus 1 times m. Then I'm going to take this divided by the 41 million, and that, if it's a fair game, it's going to equal 1 because that's how much it cost. So if I just cross multiply and I solve this, whoops, I forgot to get rid of this part. M is going to equal, in order for it to start becoming a fair game, it needs to be about 33,700,000. Now, this is not even necessarily true. That does not take into consideration taxes, or if you're going to take it over the 26 years or whatever they do it at, then they actually don't put that much money in there. If you want to take the cash payoff, you only get about 60% of it. So 50 or 60%. So that means you really have to double that. So in order to cover all the taxes and everything else in this thing to make it, quote, a fair game, it really in actuality needs to be more like, 75 million before it even becomes up in that range. So that kind of gives you an idea about how lottery works. Okay, well that completes this one. I will have another video on the other one, but I've got to still create that one.